Okay, so today we're gonna go over some applications and conversions. So last time we talked about conversions. We did different conversions, and then we're gonna do some word problems, applications. Okay, so for the conversions, we're gonna look at there's some. Let me see. There's a page with a reference page where we can just look at the different like a conversion table. And that was in page, this one, page 41. So page 41 is the reference page. So here we have the conversions we talked about last time, mega, kilo, hectare, deca, and the base unit is, hold on there, more people. The base unit is meter, gram, and liter. And also you can have second here, milliseconds, right? You know that. And these are the conversions between the land, the area, and the volume. So, and the mass and weight. So this page is 41. We're going to use this 41 just for basic conversions, okay? So going back to 39, we're going to start with number 18. So for number 18, we have to convert 15 years into seconds. Okay, so that's going to be a huge number, right? There are a lot of seconds in 15 years. So we're going to start with, remember how you do this type of conversions? You multiply 50 years. You change years to what? To days, right? So I'm going to put the years in the bottom because you're going to cancel years and years. That's the old unit. And we're going to change it to, you know, in 1 year, how many days? 365 days, right? So we're going to change years to days, and then you're going to multiply this by, I'm sorry, we're going to multiply by, we're going to change days per hour. So 1 day is 24 hours, right? And then you're going to change the hour, see days and days can cancel. So make sure it's up and down. So we're going to change the hours. We're going to change 1 hour is 60 minutes, right? And then we're going to change the minutes. So we have 1 minute has 60 seconds. So that's what you have. Hour and hour cancel, minute and minute cancel, and my answer is going to be in seconds. So we start with years and we end with seconds. And then to get the answer, we need to multiply. So I'm multiplying those numbers. I'm multiplying 365 times 5 times 24 and then times 36. So it's going to be, and I have 3 more zeros. So it's going to be 1,576,8 and 3 zeros. So this how many seconds we have in 1 year? What is it? 1 billion, right? 576,800,000 seconds. So that's how many seconds we have. Now we have to change this to scientific notation. Now when you do scientific notation, we have to move, we have to get the decimal into in here, have to be here, right? So it's going to change to 1 point because the number in front of 10 to the exponent has to be between 1 and 9. So it's going to be 1.5768 multiplied by 10. How many decimal places you're going to move if you start from here to here? How many places? 9, right? There are 9 places. So that's how you write your answer in scientific notation. Any questions?
Yeah, ma'am.
Okay, so then you're going to number 2. Mary's painting a rectangular wall that measured 3 meters by 7 meters. She wants to find the area of the wall in square feet. So here we need to change meter to feet, okay? And you have to find the area, of course. So let's see. So what is the area of a rectangular? Length times width, right? So here the dimensions are 3 by 7. So multiplying 3 times 7 is going to be 21 square meters. So now these 21 square meters, we're going to change it to feet. So let's go to the, you know what, I'm going to, let's do that. So I'm going to go to page 41 and you're going to look at meter to feet. What is the conversion between meter and feet? So we have, what we can use here. Any ideas? We have meter. From meter, you can go to centimeter, right? And then foot. You have it right here, actually. There you go. Can you guys see that? Meter to foot. Yes?
Yeah. Yeah.
So here we're gonna change 1 foot is 0.3048. So you guys remember that number? So let's put it here. So I'm gonna multiply by 1. So meter is gonna be in the bottom, feet is gonna be in the top, right? So 1 foot is how many? 0.30, what was that?
It was 3048.
Okay, so now, but now if you can see, you have meter square in the top, you have meter in the bottom. So that means you have to square this, or you multiply it one more time. So you can square everything here because it's a square. So when you square, you're gonna get, I'm gonna write it step by step so you can see. 21 meters square. We are multiplying here. When you square everything in parentheses, you're gonna square 1. You're gonna square the feet. You're gonna square the meters, and you're gonna square the number here. Okay? So you square everything inside the parentheses. So we're gonna get 1 square feet over, now what is 0.30 square? 0.3048 is 0.09290304. That's what I have in my calculator. I'm going to just keep as many decimals as possible. And that's meter square. So now I can cancel meter square and meter square. And then in order to get my answer, this is over 1. So technically I divide 21, I divide by 0.09290304. And that will give me, so the area is gonna be 226 point, I'm gonna just use 2 decimal, 04, then 2 and stuff like that after that. And this is gonna be square foot. Any questions?
Wait, how'd you get the 226.04?
I divide 21 divided by 0.09290304.
Okay.
Okay. Okay, any other questions? Because why divide? Let me explain that. Why divide? Because 21 is in the top, 0.09 is in the bottom. That means you divide 21 divided by 0.09. Okay? So if the number is in the top, you multiply. If the number is in the bottom, you divide by that number. Okay? In that ratio, you multiply by. Okay. So here we have the next one, 20. At a given point in its orbit, the moon is 2.4 times 10 to the 5 exponent miles from the Earth. So how long does it take light from a source of the Earth to reach a reflection of the moon and return? So they give me the speed of the light and they're looking for the time. So here we're going to use, so how long means what is the time? So they're asking what is the time to go and return, okay? So they give me the distance, so let me just draw a little picture here. So I have, this is the Earth, and this is the moon, smaller, right? Like that. So the distance from here to here is given, only one way, right? So this is the distance, okay, which is this number here. And also they give me the speed of the light. So here we are using the formula, the distance equals the speed or the rate times t, times the time. Okay, so if you need to find the time, you're going to divide both sides by the rate, and the time is going to be distance divided by the speed. Okay, so that's how you find the distance. That's how you find the time, using the distance and the speed of the light. So now what is the distance? The distance one way though, because it says how long it takes the light from a source of the to reach a reflector on the moon and return. So that means you're going to have two distances, right? So it's going to be the distance, which is 2 times 2.4 times 10 to the 5th. I'm going to divide it by the speed of the light is 3.0 times 10 to the 8th. And then I have to simplify this. So what I'm doing first, I'm going to simplify the numbers first, and then I'm going to take care of the 10 with exponents. So I'm multiplying 2 times 2, and then I divide 2.4, and then divide by 3. So that's what I'm doing first. Okay? So what is 2 times 2.4? I'm going to multiply it in the calculator. 2 times 2.4. And then I'm going to divide it by 3 is 1.6. So I have 1.6 times, and then I'm going to have oh, you know what? It's miles per second or meter per second. Oh, I didn't pay attention to see the units. Here it's miles, here is meter per second. So I have to change meter per second, or miles, you have to change it to the distance, you have to change it from miles, you have to change it to meters. So that means I need to multiply by something else. Hold on. We need to include that also. I just noticed the, so here we're gonna multiply because this is, the distance is miles, right? And this is meter per second. So because this is miles, this is meters, I have to multiply by changing miles. So I'm gonna put, I'm gonna put miles here and meters in the top. And I can change, I'm gonna cancel the miles. So 1 mile is how many meters? So let's go to the page 41 to see mile and meter. What is the relationship between them? You guys remember that? Mile and meter, miles and meter. So I have kilometer, right? So I have 1 mile is 0.6 kilometers, and then from kilo, I'm gonna go to meter. Okay, so that means let me write it here. So I have 1 mile, and actually I have to put mile in the bottom, and I have is 1.6. I'm gonna just use 1.6 kilometers, right? And then I'm gonna multiply, I'm gonna put the kilometer in the bottom and meter in the top. So if you do that, how many, 1 kilometer is how many steps? 1, 2, 3, so it's gonna be 1,000 meters, okay? So they're 1,000 meters in 1 kilometer. So that's how you're gonna continue from where we are right now. So I'm gonna multiply, let me write it here. So I'm gonna multiply 1 mile is 1.6 kilometer, right? But I need to go to meter. See, mile and mile cancel, and now I need to change 1 kilometer is 1,000 meters. So kilometer cancel, and we have left with meter, and this meter is going to change with this meter. And my answer is going to be in seconds. Everybody understand that? So here, when I multiply these three, the yellow numbers in the yellow, they're 1.6, right? So I have 1.6 times 1.6 times this 1.6. That's 2.56. And then let's do the tens. Times 10. Now, here we have 10 to the 5th, 10, 8 in the bottom, and this 1,000 is technically 10 cubed, right? So how you do the tens? We're gonna add 5 plus 3, and you're gonna subtract 8. So 5 plus 3 is 8. So in the top you have 10 to the 8, and in the bottom you have 10 to the 8. So technically all the tens are gonna cancel. It's gonna be 0, right? So there is no, we're not gonna put times 10. So it's 2.56 what? Seconds, because only the second is left. Oh, he's doing that. Okay, got it?
So you multiplied the 2 and 2.4 and
Yes,
1.6
yes,
to get the 2. Okay.
yes. And then divide by 3, and I get 2.56. 2.56 seconds. Now my computer, it's something going on, and I can't do anything right now. I can move it, so I need to close this window, I guess. So some of this is gonna disappear. So if you wanna copy that, it doesn't let me save, nothing. I can't do anything here. Okay, so did you guys get these notes?
Yes, ma'am.
Okay, so we're doing 21 right now, number 21. We have to draw a rectangle that has the area of 12 square feet, and convert the area to of your rectangle into inches square. So we're gonna, I'm not gonna draw the rectangle, I'm just gonna change feet to inches, right? So I have 12 square feet. If I want to change to inch, I need to know how many. So I'm going to put feet in the bottom and inch in the top. But because this is square, I'm going to square everything here. Okay. So what is that? 1 foot is how many inches?
12 inches.
Well, everybody know that. Good job. So here we're gonna again square everything inside the parentheses. So we're gonna have 12 square feet. We're gonna multiply by 12 times 12. You square everything inside, right? So 144 inches square over 1 square is 1 square feet. Now square feet and square feet cancel. So I just have to multiply because 12 is in the top. 144 is also in the top. So what I need to do is I have to multiply 144 multiplied by 12. And that's 1,728 square inch. Okay. So now the question is, so we transfer, right? 12 square feet and 1,728 square inch. It's the same area, okay? We just changed the unit. So do the side length you choose your rectangle affect the answer in part B? What do you think? So what do you think about that? So the side length, which means you have rectangle, right? So let's say this is the length, this is the width, right? And the area is everything inside, right? So is the area gonna change if you change the length?
Yes.
Yes, right? But here, do they give me the length and the width in the original answer? No, they give me the total area. They give me the area.
Mhm.
So technically, if you change the length, the area is given. So if the length is changed, the width also is going to change. The area is given. So if the area is given, technically the length by itself doesn't affect the area. Or do you think that it's affecting the area? So
No.
you can, no, because your rectangle have to be with area 12 feet. So it could be 6 times 2, right? That's 12. It could be 3 times 4. That's also 12, right? So it doesn't matter what's going to be your length. It's not going to affect the area, right? The area is going to be 12 feet. So let me write it here. So if you pick your rectangle to be 6 times 2, the area is going to be 12, right? If you pick your rectangle to be with size 3 times 4, so it's going to be, I mean, it's still going to have the same area, right? Yes, the area is going to be the same because that's what is given in A. In A is given the area, which is 12. And if you have the area 12, then you're just changing the area to the feet to 2 inches. So it's not the side of the rectangle is not affecting your answer. Make sense?
Yes, ma'am.